Hello. Right, let's see if we're started. I think we are. There's my chat box, there we go. Hello, I'm ED-SKaR, and today I'll be doing a live stream of some 3D modeling, and specifically that's for the Nerf Kronos to make a holster for it. I've made a holster for the hammer shot previously, and so someone who bought one of well, actually a pair of my hammer shot holsters has commissioned me to do the same for the Kronos, and I said, give me a Kronos, because I don't actually have one. So this is actually his Kronos. And so I'm just going to get started. One thing I want to do immediately is to calibrate my printer. Kind of, not really calibrate my printer, but calibrate the part that I make for my printer to make sure that it comes out correct. So I'm going to make the profile here. Actually, let's point it at this camera. I'm going to make the profile here all the way around, and I'm going to make just like a 3mm chunk, just a little ring, so that I can test fit it and then print that. And while that's printing, I'll design the rest of the holster. So, well, I'm going to get started by zeroing to the Z-axis. And I need to make sure that's like that so I can see the chat box in case anyone decides to join us. Yeah, close enough. So widest diameter there, sorry, widest point, and that's consistent all the way down, so that would be 58. And the height, let's go, so I'm measuring the height. I'm actually going to measure to the white surface here. I'm going to not measure the rail just yet, and I'll build that up separately. So that comes in at 98.2, so if I make that 99, gives it a little bit of clearance. And of course we're going to print off that test piece and we'll dial it in correctly from there. Right. So I want to make a slightly thinner section for the bottom here. So let's bring that in to, ooh, that's going to be 41. What's half of 58? 25 plus 3. How do I maths? I forgot to turn my brain on today. It's 29. Yes, it is. And I want to make that, doesn't need to be too big here, 15mm will be fine. And how, it's 41, wasn't it? Yeah, basically 41, so if I make that 20.5 each way. Okay, so that's got the narrowing at the bottom for this part. And I think I will try to find the widest part, which is probably on this lower section here. See if I can get some contrast on this camera. There we go. That's just about right. So the tallest points are these kind of here and here. It's these rivets, and then there's two. There we go. There's two just there. So those are the widest points. So I want to measure how big they are. I got 47 here, and how do I measure that? Terminal 2.7. So if I add a mil on each side, okay, 49, 50 mil. So let's just make that 50 millimeters wide. It wasn't 28, it was 29, wasn't it? Yeah. There we go. I should have drawn a center point. In fact, I can draw a center point. There we go. Center line. They're handy. I've drawn it in the right place, right? Yes, I have. Good. What was I doing? I can't remember. Yes, I was doing this. 50, so 25 millimeters each way. That was crazily convenient, and that wasn't. So what is that? 1, 2, 3, 4. 4 million. And so this is for everything kind of under this bulge here, so I want to measure that as well. $35, sort of. Yeah, let's call it 35. That's in the wrong place, isn't it? Yes, it is. Because what it should be is cutting out this area. Is that lopsided? Does that look lopsided to you? No, that's even. Okay. Let's cut away some of these corners to make it a slightly tighter fit. One of the things people have said about my Hammershot holster, one of the things that is liked about it, is that it is a very tight fit, to the point where it does tend to scratch paintwork on painted Nerf guns. So kind of good and bad from different points of view. So I reckon that's going to be 45. That's nice and easy. So 8. 1, 2, 3, 4, 5, 6, 7, 8. From there we go, 45 degrees. Bang. What? How did you? There we go. Better. Also like the idea of cutting up here as well. So let's have a look at that, which also seems to be say that was probably also 45. Maybe it isn't. Maybe it is. Let's go with 45 because we know we're going to be testing it momentarily. Has the stream crashed? It seems to have slowed down there. Hello, Meow. How are you doing? Hello, Gabby. I'm doing alright. I've basically just got back from work. I've measured that wrong, haven't I? No, that's fine. I need to just... If I sit straight onto my screen, then I won't be having the constant... this Kronos isn't mine. This Kronos has been loaned to me for the purpose of making a holster. Which is, in fact, what I'm doing here. So just to bring you guys up to speed, because I haven't worked out how to start a live stream on YouTube before you actually start the live stream. Everyone else seems to have 3 hours until the live stream starts. I can't work out how to do that. So I kind of start my live stream and hope people turn up. What I'm doing is I'm building a holster for the Kronos. And to start with, I'm building the profile of the front here. And I'm going to print just a 3mm, like a ring, because that's very, very quick to print. And it will mean that I can slide it on and I can see if it hangs up on anything. So I've measured out things like these kind of rivet looking things. Let's see if I can show them up on camera. There you go. So there's these rivet things here and other lumps and stuff. And I've tried to make it so that what I'm building here, this ring, will slide all the way down to just in front of the priming handle. So it will completely cover this. Once I've tested, once I print out that little ring and put it on, then I know that everything else I make after that is correct. And if it's not correct, I can just adjust it, which is fairly easy to do. So the last piece of the puzzle, 22, is to build just the shape at the top for the rail. So I'm just building a hole for where the rail goes now. So that's 11mm, and how tall is it? Ah, we better get the front sight as well. I'll do the front sight separately. So that's 7. Get rid of all that. So that's for the rail, just a great big opened chunk, because this is not... will the rail be contact surface? No, it won't be. It'll be this corner here, and then it will be the base here. Those that will be the main contact surfaces that line it all up. Right, and the sight. So I just need to build just a tiny little hole here for where the front sight goes, which is 5mm, so 2.5, and is 3mm tall. And box the other way, going 5mm. Now that should be... Does that look right? It kind of is that tall, isn't it? How's the audio for you guys, by the way? I haven't actually kind of jumped on as soon as I got home from work, so I haven't tested the audio. I wonder if there's a quicker way of doing this. A select all. That would be nice. So the thickness only needs to be probably kind of 2 mil. I mean 2 mil for the test piece. Let's make it 3. Oh, I guess it's 2. And let's pull that by, let's make it 3 mil tall. Let's make it 5 mil tall. There we go, that's better. Right, so what this is just a ring. It does look kind of similar to a Nerf sear catch, doesn't it? Yeah. More by coincidence than anything else. There we go. Right, so I now have to start up my printer. So we're going to save as, actually let's save it as the RS doc first, and then save it as STL. And we'll open up Cura. No, I don't want the new version of Cura that's several years out of date now. Where are we? Kronos, Kronos, Kronos. Let's put it down in. Yeah, that corner's pretty clean. So don't just worry about any of that. So that's going to take 27 minutes. That's half an hour. Realistically, it's going to take about 45 minutes. Save G-code. Ah, there's a file on the card here for a canted flywheel cage for a Strife. There's a spoiler for you. Okay, I'm just going off camera for a moment to turn on the printer and get that printed. Alright, so while that's going, let's close some of this down and get my chat box back. There we go. Lovely. Right, so while that's going, let's get this, the rest of this designed. So the lowest, kind of the most forward point on the Kronos, which is when it's holstered, the lowest point, is actually the barrel itself. But I don't want to risk damaging that. I would rather use this surface here, or even this surface here just above the barrel, as the contact surfaces at the bottom. So I'm going to build some bridges to make that the contact surface. In fact, I'm going to have a go at building both. So which way do I build that from? Let's build it from this. It should be the underneath. Yes. So this is the underneath. Home view. That's not quite what I wanted. I wanted plan view, didn't I? There we go. That's better. I totally know what I'm doing. Totally know what I'm doing. So drawing down from here. 9.5 is close enough. Yes. Can you please go there? Yep. Okay, so that eliminates the lip. Not sure if you can see it just there. So that this line comes just underneath that lip, and then I want to make another line just above where the barrel is. So that's 21, but let's bring it down to 18 so we've got a nice bit of clearance. Let's make 18.5. Fine. You've convinced me. So this wants to go, at the very least, 3.5. So that's now a surface, kind of a bridge that will rest against just here above where the barrel is. So let's make another one down at the bottom, which actually, realistically, I don't need to measure all that well. Let's go plan view again. Bam. Because I can go all the way up to about there and just call it 40 mil and that'll be fine. Close enough. However, this is going to be more difficult to measure because I need to measure from the front surface of the barrel to here in this plane, in this direction. And if you see, it goes from the barrel, it's got this angled surface, then a flat, and then it rises up to the actual surface I want to measure to. So that's a bit difficult. I can just about measure. Let's see if I can hold up to this camera. Oh, that camera is horribly grainy. I can measure to the lowest surface from the barrel, and I get 7.5, and then I can measure from this to that lowest surface, and I get 1. So that's 6.5. 6.5. Yes, so minus 6.5. It's actually, of course it is, because we only made that 5 mil at first, didn't we? How are you getting on? Aha! So the print bed's warmed up and the nozzle is just heating up now. How's the sound on the printer there? Is that kind of washing out my voice, or is it okay at the back? Yeah. I've gone quiet again, haven't I? So these are just some drainage holes at the bottom to make sure that if dirt or water or anything like that gets into the holster, it has a way to get out. But it's also small enough that you can't shoot through it. Not that safety concerns are important for Nerf, but the idea of making sure that a holstered pistol can't shoot is generally a good idea. Okay, the next consideration is just how far up do we take this? And I'm pretty sure the answer is to this, because I forgot to measure it. Go me. Although that does mean we can create an extra service. Thank you, Mr. Nathan. That's exactly the thought that I needed. Yes. Sweating out of its holster and it needs some way to drain. Marvellous. That's not the correct way to measure that. So that's 145 to there, but then there's also this bit. Yeah, prepared for everything. Gotta look after it. That's what the holster's for. You got to look after your pistols. So that's 3.5. What did I measure? You've made me forget what I was measuring. I measured it and everything, and now I've forgotten what I was doing. I don't know. I keep on missing your live streams because you live on the other side of the planet, and for me, you're streaming in the middle of the night. So yeah, it's 145 plus 3, 148 minus the 5 that we've already done. So that's 143. Boom, there we go. And that's the holster. Well, it's not, but that's kind of the general shape of the bottom half of the holster. Yeah, I'm definitely going to thicken up these. I should have gone for 3mm originally. Oh well, it'll live. So that only brings us up to this lip here, where this kind of lump just behind the jam door is. Jam door, access door, loading door? What's that even called? Doesn't matter. Brings us up to there. The surface I'm actually interested in is this surface here, and I can't get any contrast at all on that camera. That's like, I'm working with the cheapest cameras in the known universe, so it's yeah, contrast. Which angle do I have to? Oh, there we go. So on the hammershot holster that I made, I used the front side of the trigger guard as the locking surface for the catch, the holster catch. On the Kronos, however, this surface here is angled, and so any catch that goes in there, just pulling on the pistol's grip will push that. Just the angled surface will act as a cam and push it out of the way, which is the opposite of what you want to happen. However, there is this convenient flat surface just here. It's very small, but it's big enough for what we need to do. So this flat surface here is what I'm going to use as the locking surface. So I'm going to build just a little lever, little catch here, so that when you grab hold of the pistol in the holster, you have a button just there that you press, and it raises up the section here. So it'll be there'll be a metal pin about here. The button will be this side, and then the locking surface will be here. So you push the button, locking surface rises up, and then you can draw the holster out. Otherwise, the locking surface of the catch will be pressed up against that surface, and it will hold it in place so that it won't go anywhere when you don't want it to. And it's not at the same level as this. Fantastic. Just what we... Yeah, good grief. Right, let's make sure to zero this every now and again to make sure that I haven't gone wandering off. Conveniently, though, I can measure, just like that, a single measurement to the surface that the bridge that I made for the front surface. And that's a nice, neat 145. It's almost exactly 145. So I can come inside here. I'm going to need the keyboard for this. Am I? Am I going to need the keyboard? Ooh. Measure from there to there. See what we've got working with so far. So that's 141. And I've already forgotten my numbers. I'm good at this whole remembering numbers thing. So we've got 145, and that's 141.5, so it's 3.5 millimeters further that we need to build. Remember that, guys, 3.5. In fact, I'll remember it for you. There you go. Anyone reading the chat afterwards is going to be totally confused by why I just said 3.5 millimeters in the chat. But that is a useful tool for me. Let's not draw this line. I actually need to go and build this raised section in first, and it's 2 millimeters, which is marvelous. It's the same as the thickness I've made this, so that's not what I would want. Okay. So it comes in, if I show you from this and draw my finger across it, so it comes in all the way across the top, but in the middle it's behind where the rail is, so I don't need to worry about that bit. But here at the side it comes in beside the rail, and it actually goes down onto this angled surface as well, but then it stops just there. So I only need to build it here and here, and then on the other side here and here. So I'll do that. However, because it's easier, I will actually build it straight up from there. And of course that's not going to lead me to that. And from there we'll go... Should we go all the way to the... No, let's draw a line up from here. $135. I have the horrible suspicion that I've got some horrible numbers somewhere. In fact, yeah, I do. Why is that not parallel? Oh boy, here we go. Now I've got to go and find out where I've messed up previously. It's this, isn't it? It is. Great, okay. Let's get rid of that line. Rubbish. Absolute rubbish. How have I drawn that in so badly? What was it supposed to be at? Oh well, when I go to redraw that, it will all fall out. Will it? Will it though? Will it fall out? Let's pretend it will and hope. How far was I put? Oh, I wrote this down so that I could remember. 3.5. Yes. Excellent. And now what we have in here, these bits here, in theory, match up with this lump on the top here. And now, also in theory, this surface, when the pistol goes into the holster as it's currently designed, in theory, that surface that I've got selected lines up with the surface that I'm using as the locking point here. So what I can do now is start to build the catch. Printer's happily chugging away there with the test piece. Yes, yes, you're absolutely right. In theory, is the most dangerous term to use. In fact, in theory is not even the correct term for this particular, because it's not a theory. It's a theory is something else. But you're right, very, very dangerous to be talking like that. Why are you clicking? Can you hear that clicking over the microphone? So I want to go 34mm up. As long as it's not distracting or anything, it's not too much of a problem. If it gets too loud, at any point, let me know and I'll... well, I don't know what I'll do. I'll turn my microphone down, I imagine. Right, so I should have done those as construction lines, but oh well, too late. Too late to be sensible now. So I also need the thickness here. Where am I working from? 44. So this needs to be 11. Half of 44 is not 11. Half of 44 is 22. There we go. Why are you not even remotely straight? So from there, that's that corner. So go 3.5 mm. I'm actually going to draw this. I'm going to be sensible and draw this as construction lines, because I want this box that I'm building now to hang around, but I don't want to actually make anything else of it. $14, 3.5, and thought you were going for quarters. Quarters? I don't understand the relevance of quarters in this context. Quarter gallon? Quarter pints? And I've just deleted one of my construction lines. Right, there we go. So what that is, that construction box that I've just put in, is the useful locking surface that I'm going to be using. So the catch that I build, when it's in the closed position, I need enough of it covering that box that it will hold the pistol in place. But when it's in the open position, I need it to be completely clear of that area, which makes it nice and easy. Now the button can go, I mean realistically the button can go all of the way down here, which means the hinge can go, actually the hinge would quite nicely go on that surface there. Yeah, good, let's do that. Let's also build oh yes, a quarter of 44 would be 11. But no, I didn't want a quarter, I wanted a half. There we go. That piece there is just for the printer, so that as it prints up, because it's printing like this direction is towards the print bed and this way is up. Go away. So this is towards the print bed and this way is up. So as it prints up here, it can't print in the middle of the air. So actually, let's not do that. Let me rotate it around so that it's going to be printing in sort of this way up. So as it prints here, it can't print this in nothing, but it can print out a little bit. So if I start it off a little bit at a time, it will be able to print up to here and have and print this area. So that's all that's for. I'll also probably build by... Could have just done that in the first place, that would have been easier. Why would I ever do things the easy way? That's a terrible idea. So from here down to there, so that's already 24. Half of that would be 12. I need 3.5 millimeters of travel, which that's actually nothing. So, yeah, let's go for 12. So let's put the hinge, the axis point, let's put that there, and let's pull that surface all the way down to the print bed. What's that done? Why is that not solid? There we go, that's better. Ah, don't do that to me. There we go. So this circle will be the center point of my of the axis for the catch. "3D printed solid Kronos holster. I haven't seen that. Do I need to be distracted from the... Yes, I do. Ah, no. Better, arguable, but different. My holsters are designed quite differently from how 3D printed solid holsters are designed. They're going for very, very minimal material that holds onto the holster and gives for a very quick draw. My holsters are more designed to be a complete case for the... they're not case holsters, but they're a complete covering for the pistol to protect it as much as possible. Given that a lot of people I know play at the Caves in London, there's a... I'm not a shill. Anyone in London, go play at the Caves. It's a lot of fun. It's very dark, but it is it's an old abandoned chalk mine, and running around there, you scrape up against the walls all sorts of nasty. So having having gear that protects itself and protects your equipment is a good idea. So it's sort of designed for that kind of... Thank you, Gabby. Yeah, it's sort of designed more from the protecting the holster than a kind of speed draw kind of thing. The 3D printed solid is a very good, almost a race gun holster. It's designed for that very well. Whereas mine's more of a military style protecting the pistol holster, which means it's heavier, more expensive, and there are pluses and minuses to each system. Is what I'm getting at. Right, so what I want to do now is... Yes, I do. I want to go up 1 millimeter from here. And now I want to start building the catch. And the reason why I've built this up 1 millimeter is because I'm cheating horribly. Don't do that. That was the sound of filament snapping. No, it's okay. Yeah, it's fine. It's fine. Don't. Yeah. So I've gone up by 1 millimeter because I'm cheating with the software. I'm doing things the easy way rather than the right way. Just remember, there's always an easy way and a right way. And for the easy way, one of the considerations is that I can design this here. Now that I'm 1 millimeter up, I can still see all of this. So I can just draw the lines in where I want them for the catch, and then draw it up as a 3D shape, and then I can delete this little 1 millimeter section, and I can pull that piece out because it will be separate, rather than doing things properly. Because why would I do things properly when I can do things easily? So let's go for... Actually, no, let's not do that. So one consideration to make is that because this whole piece is rotating around the axis point here, so this is the axis of rotation. So if I was to build this as a square, let's say I built it up here as a square or a rectangle. If you notice, I'll just put that. This piece here is now outside that circle. So as it rotates, it's going to be outside of the circle here, because this is tethered to this point. And it won't fit because I'm going to make that piece solid. So what I should always start with in this kind of thing is the circles at the maximum and the minimum, and then I will build around that so that when the shape is complete, it has the sloped surfaces or wherever it's coming close to an existing part. And that means that it shouldn't interfere, it shouldn't catch or bind up at all. In theory, hopefully. I actually pull this all the way down. Let's get rid of some of this. There we go. Lovely. So I'm going to go in 0.5 mil. Yep. Yeah, that's okay. So what I've got is I've got a 3 mil by some more mils surface on this part that's going to interact with the surface on the Kronos and holds it into place. I also want to build on the other side a button that comes out by the same maths. How does it work? Right. So this is the furthest point in, and this is the furthest point out, which means that whenever the button is the base of the button can be here and it'll be closed, and pushing it in this much will open it up. So that's a very short travel. That's just over 2 millimeters here and more like 5 millimeters further out. But I don't want to come out further than the actual profile of the holster, because that's just asking for it to get snapped off. So what I'm going to do, this clearance here is fine, so I don't need that. So I'm going to build it around this line here. How big do I want to make it? I want to make it pretty chunky. Could build it all the way to there, actually. No reason not to. Make it massive. It's kind of absurdly massive, actually. There, yes. Now I also need to build in here retention for the spring. And I've kind of worked myself into a corner to an extent. Just a little bit. But I think I will be okay if I draw in that line. I could build it out here. I don't want to build it out there. At risk damage it. I could just build it into here. And I can sit a little bit. Yeah, that's what's happening. So I'm going to build it into... Yeah. Unfortunately, I haven't actually got the spring that I'm going to be using, which is a monumental oversight. But I'm going to build a placeholder for the shape. Oops. Oh, of course, I'm on the wrong level. So I actually do need to make that, yeah, make it like that. Because that needs to come down by 1mm because I've raised up by 1mm. Sensible. Then if I also build a comparative flat spot there, so that when I come to build the hole for the spring in these two parts, they line up. 1, 2, 3, 3mm. Do you think 3mm is big enough for a spring? I think it will be. How big do I want that? 10mm should be enough. So there we go. That is the catch built, although it's still attached. Let's detach it. There we go. And of course I've got a whole bunch of separate pieces. Why? I don't need that. I need that. Don't need that. It's the biggest problem I have with this particular piece of software is that when I build odd shapes like this, when I particularly when I layer stuff, which is how my brain works, so that's how I work, I end up with these separate pieces, and it's so annoying sometimes. And I'm just not sure how to make them join up, even though there it combines them. If I draw that the whole way down, and no, it doesn't even do it that way. Sometimes it does things, it combines shapes that I don't want it to combine, and then sometimes it doesn't combine things that I do want it to combine, which is altogether rather annoying. If I minus 1 there, ah, see, that has combined with the rest of it. Anyway, let's go for, oh no, let's not do that, because I need to be able to build it from there. Well, actually I can do it that way, because I know where that line is. That line is there. I can just do that, and here I can just put it about there, roughly. That. 5mm, and then pull it all. Can I combine this surface? No. That goes by 9. So there we have the hole forming. Oh, of course, yes. I built this at 10mm, but I've got an offset, and then I've built this by 10mm, so it's 1mm short. Equivalent to the 1mm offset, but that's fine. I will be making this piece slightly smaller eventually. But what I can do for the moment is move it out of the way. Well, actually, what I could try can you please, can I move you? Okay, you won't let me move you, fine. Yeah, there we go. Right, now I can move it out of the way. Because that will be printed separately. Right, then let's go back to here. And I'm just going to rebuild over the original line because it will when 3D printing there's a setting on pretty much all printers to just make standard infill material. But I do need that circle, don't I? But that circle doesn't exist on this plane. That's fine, I can fix that later. So if anything lines up with upper levels, there's an automatic setting on most printers that you can fill this with infill material, so that which is very weak and crumbly, so that you can break it all away and have this hole. And I've not lined that up. Did that line up? Yes, it has. So we've now gone 10 millimeters up from here. So we're sort of at that level. And it's starting to go dark here in England, so probably going to have to cut it short. But we're basically done. But from there to the priming handle, which is where I wanted to go to in the at the top end, so that's 30. So if I take this by another 20, there we go. So that is now the holster, which will cover up to there on the Kronos. I could build a shroud that covered the top, but that would take another 10 hours to print every time I wanted to. I may end up doing that. I may end up doing a kind of a full holster that covers up here and you just have the grip exposed. I'm also definitely, because someone's already asked for this, I'm going to do a cut down version that's cut at an angle like this. More of a speed holster than a covered holster. Not quite as minimal as the that other holster, but what was it? The 3D printed solid holster. It's going to cover more, but yeah, it'll be a different version. One thing I really need to do is work out how to combine these solids, because they're not going to print very nicely. See that? Combined with one side, you can see there, if I select that, it combined with this side, but I did exactly the same process. But doing it to this side didn't combine it, because of course it didn't. Why would it be helpful? SKaR holsters will be available. Well, given that the SKaR is an assault rifle and is kind of this kind of size, you don't so much put a SKaR in a holster. SKaRs, you usually put them on a sling. I mean, if you want me to make you a holster for a SKaR, I can do, and get hold of an Airsoft one, measure it up, print that. I mean, that'd take a week to print. Oh, you mean ED-SKaR brand? Of course, ED-SKaR branded holsters. I do already print hammer shot holsters which I do have one on my... One moment, I can get that. So this is actually my airsoft rig with a Nerf hammer shot on it, because of course I have a Nerf gun on my airsoft loadout, because I'm just too good and I need to be nerfed. Funny. Yeah, anyway, I need some light. Let's see if my desk lamp can... Oh, I can't actually see that way anymore. So this is the hammer shot equivalent of what I've just built for the Kronos. Actually, I probably should just quickly hit that save button. There we go, so I don't lose what I've done. Yeah, every time I make jokes, it just tumbleweed and crickets. Absolutely. So as you see, it's the same sort of thing. It's a complete block of printed material that the pistol fits into, and you've got the grip and the kind of the back of the top there sticking out. Difference is with the Kronos, it's got much more sticking out at the top, and wow, that's gone. That's really white. There's much more sticking out the top, so there's more exposed. But the hammer shot's that nice kind of shape that it there's very little exposed on that. But it's got the same sort of catch that I've designed here, which fits into, and again, glare, light. How does lighting even work? That's oh, there we go. That's sort of nice. So this surface on the front of the trigger guard is what I was talking about at the beginning of the stream. You may have missed it, so let's just describe it again. So this is a flat surface, flat in line with the... I think it is. It's flat in line with the draw axis. So you draw in this direction, and this is flat in that plane. That plane is, yeah, whatever. I think you understand what if you don't understand, tough. I can't explain any better. I'm running on 4 hours sleep like 16 hours ago. So you got this flat surface, and that's what the catch locks into in the holster. Let's get the light back because that's dark. And then you've got this catch, and let's see if I can get this angle here. So there is a spring hidden away in this. I've built a bit of superstructure underneath, which I've sort of kind of built here. This needs to be a lot bigger, but it's underneath the tab, and so this separate piece here on the printed design is this block kind of that runs that way, and then I've put a nice big circular pad there so that when you grab the pistol, it's under your trigger finger. You press that and your trigger finger's in the right place, ready to go onto the trigger, as you would expect. And conveniently enough, the next pistol along is an Airsoft 1911 in a CQC Black Hawk holster, although it's a copy, it's not a real one, it's just an Airsoft copy. And it has a similar sort of thing. It's shaped for the front of this pistol. In this case, this is a replica 1911, and it has the same kind of tab that locks into the trigger guard. Although this one is very low profile, it's actually inside the material of the holster, and you have the button. Kind of the top surface of the lever is the button, and that lets you draw. And it covers up the trigger. It gives you access to the safety catch and magazine, so you can do anything you need to do with the pistol safely. Similarly, the hammer shot holster, it keeps you away from the trigger until you draw it. Loading, there's no magazine on this, but loading it would require you to pull it out because you can't really access the front. And that was the sound of my 3D printer being done. So let's rip off that, and I'll show you what I made at the beginning of the stream. How easy is this going to come off? Fairly easy. So this is the very first thing that I made. This is essentially the profile of the shape that I've extruded to make the entire holster. But the reason why I printed this very, very thin piece is because this took half an hour to print. well, 40 minutes according to the printer. But what it means is I can just put this on and test it versus the Kronos. And as I expected, it doesn't fit. Let's get that light a bit further away. And we can tell what I didn't account for. So it does actually kind of go on with a bit of pressure, but obviously the pressure is not what I want to do. Okay, so right at the front, let's see, try and get it on this camera. No, not quite. There is this really tiny lump just here. And from the front, you can see there's a lump on both sides, and that lump just intersects with the corner of the white to the orange. So I didn't take that into account on my design, so I'm going to need to cut that in, and that is here. So that's, can I get going? So that's this corner here needs to have a bit of a fillet. It's probably just a fillet will be fine. Also, this bit at the top here is not quite big enough. Nearly, but not quite. And the bottom, no, that all seems to fit. That all seems to fit. Actually, that does kind of slide in there okay. I think it really is just those two little tabs on these two corners here and then on the other side equivalent. Because other than that, it sort of does kind of line up. So I did save recently, didn't I? Save again. Save. So that's this surface here. So how much of a fillet do I actually need? One and a half millimeters on each side. Although first what I want to do is, before I cut away at the inside, I want to make sure there's enough material. Let's make that chamfer. There we go. Nice. I want to make sure there's enough material on the outside so I don't cut all the way through. And let's go onto this surface and build my little shapes. Rotate. So it's 1.5 mil by 3. There's an easier way of doing this. Add stuff to the outside, make sure there's enough material. Let's give that 2. And let's take off 3. There we go. So that will now fit. Well, not there, it won't. Get rid of those overhangs. Oh, of course, this is a separate piece. Why are you still a separate piece? However, I can do it the easy way. Well, I say the easy way, it's nothing's easy, but it's not the hard way. There we go. So in theory, and there's that term again, as far as I've designed this, this should now slide in nicely over the hammer shot. Hammer shot? This isn't a hammer shot, this is a Kronos. Should slip over nicely over the hammer shot. I just said it again. Kronos. This surface and this surface here go here and here so that the barrel doesn't touch the bottom. So that's protected. Given that it's not really part of the air system, but I want to keep that away from being damaged in any way. We've got the catch nearly built, I need to go through my parts bin, find a bunch of springs and a pin to decide what I will use that for, and build up the guide for the pin and the guide for the spring, and that's it, sort of. That's pretty much done. What time is it? It's just after 8 o'clock here in England, and it's completely dark outside. I will do one more thing, because I want to make a flat surface here, because this is the side that goes up against the body. So I want a flat surface here to put my molly panel on. I've got a molly designed for a molly loops and some tabs as well that I can just throw onto any part very, very easily, rather than designing it over and over again. So I just need a flat surface to do that with. So let's go into here and work out how I'm going to do that by simply, actually no, how far is that? 4 millimeters. I'm going to make this easy for myself. 4. There, that was easy. That's a great big flat surface, so I can put on the molly loops, or I can put on I can design a belt loop or something else. If I have specific measurements for something, I can put that in place there. Let's go back to this, and people are talking to me. Don't talk to me. And again, as a placeholder, I'll just put a 1 millimeter hole there. I'm almost certainly going to use a pin that's bigger than 1 millimeter, but this just gives me the option to very easily minus. I need to really go -4, yeah. Because what I can do is I can click on that, and it says 0.5 because that's the radius, not the diameter, and then I can enter in any number I want for the pin, so that when I get a supply of pins, I really need to just buy a bag of like 1,000 pins and a bag of 1,000 springs for these holsters. Maybe not 1,000. I probably won't make that in my lifetime. 100. Let's go for 100. What's that? That's not important. So it really is just that piece. All of the others. What's that? Okay, you can go away. I'm just cleaning. This is my my equivalent of room cleaning. So it's just this piece that's refuses to join in with everyone else. Yay! I got it right. That is an overhang. That didn't work. Yeah, that'll do. So overhangs, I think I mentioned this previously in this stream. 3D printers don't like to print flat surfaces with nothing underneath them. So either they use support material, which I don't want to run support material all the way from the bottom all the way up the side. That's a lot of kind of wasted filament, and it sort of spoils this surface. So if I have a kind of slanted surface there and there, that means that I don't need support material for that. I can just print right up to it. Or I just pull that all the way down to the bottom. Yeah, that's the better option there. And that looks a bit neater as well. Alright, my cameras are starting to get to the point where I can barely see what's going on. I'm not sure if you can see. I hope you can see at least something. But that's the main part of it done. I need to get some springs, some pins, and just adjust these designs, which takes all of 2 minutes, and I need to put the molly loops on, and then it's done. So I'll end the stream there. Thank you very much, everyone, for watching. Let's see, who have we still got? No one. According to my participants, no one's still here. Anyway, thank you very much for everyone watching and anyone who's watching this recorded. And I will see you next time for the whatever it is I do next.